All right, is there anybody out there and can you hear me? If you can hear me, type into chat there. Let me know you're there. We'll give it a couple more minutes and then we'll get started. I know this is new for people. Um, if anybody happens to be watching, I know that some people sent this out onto Facebook. Let me adjust this just a little bit. Um, Go ahead and go to scratch.mit.edu like we have here on the screen and sign up for an account if you don't have one. If you do have one, go ahead and log in. I'll talk a little bit today about what we'll be learning, and then we will get to putting some code in here. And it's not this code that you see on the screen. It is going to be different. We're going to do a little bit of computer modeling today. Oops, wrong screen there. Just making sure that this stream is up and running. Washington Crafter, hi. There's someone there. That's good. I'm not going to know who all of you are just because of the names. Oh, it's Bailey. Hey, Bailey. Is everything look out? I can turn it down. So let's just wait. Let's see if anybody else hops in here and give it a few minutes. Again, this is new to most people, so we're going to wait just a little bit. It's fine? Cool. You're going to notice a bit of a lag between your typing and me talking. There is typically about 10 seconds between what I say and when you hear it. It's really awkward. We're going to give it about 5 more minutes, then we'll start. Just to let everybody know, this is probably what we're going to be doing for a while here. We're going off of the same ideas that the schools are going off of, the same goals, to keep kids safe, and not just kids, but parents as well. And don't worry about your spelling. I'm terrible at spelling. But anyway, we're trying to focus on protecting not just the kids, but kids aren't necessarily impacted by the COVID virus. It's the family around them that gets impacted. So grandparents, parents, even great grandparents in some cases, those are the people who are susceptible. So we're probably going to be learning this way for a long time. Since we're going to be doing that, we are going to be just we are going to be kind of upgrading what we have here so that me and the other teachers, as we do this, will actually have better equipment. Right now, I'm using a cheap microphone, and I got the headset on so I can hear myself, but that is going to change a lot. We are going to we're gonna. I already ordered a nicer microphone so that you won't be able to hear things like mouse clicks and whatnot. Like if I click my mouse over here, um, see my microphone says that it's picking it up. If I'm quiet here for a sec, see you can probably hear that. The microphone that I just ordered, it will only pick up the person that's talking. Um, we're going to make it to where this is something that we can keep doing and keep doing well. So we might not be meeting for a while, which is a bummer. All right, let me set up one thing here. And if you guys type too much obnoxious stuff, I actually have the ability to review it, just FYI. So I can see everything that comes through. Okay, so let me get signed in here and get into an account that doesn't have anything. We're going to go to create. So what I want to talk to you guys about today, what we're going to learn about today, is what we've been doing and what we're doing right now, and that's called social distancing. So social distancing is a way of containing a virus, or in this case, what's a pandemic. Now, a lot of questions are being asked on how do we know what to do? How do we understand what's going on? How do we know this spreads? And how do we know that keeping away from each other, besides trying to use just a little bit of common sense, but how can we prove that keeping away from each other will actually continue to curb this and stop the spread of a virus? Well, we can do that with computer science. We can do that with code, and that is through computer modeling. So this is a very, very easy computer model we can build. And what we're going to do is I'm going to show you guys today how to build this. And we're going to build it in Scratch, and we're even going to build a little graphing simulator that will show us the infection rate as our infection spreads throughout. We're going to use little dots. Okay. And you might be the only one in chat right now. Other people can actually see it and not chat. It's one of the abilities that you have with YouTube. If they want to chat, though, they can log in, create an account, and log in. Create an account on Scratch, create an account on YouTube. You can log in. I am marking these as not just for children because I want to be able to chat with everybody. If I mark these as for 18 and under only, it actually disables the chat completely. But I want you guys to ask questions. I want you guys to have opinions as we keep working on this. I don't want to just talk at you. I want to talk with you. Okay. Also, to that point, anybody over 18 can watch this and still get an idea of computer coding as well. So it's not just for kids. So the first thing we're going to do is I'm going to name this real quick just so we can save this and have it save as something appropriate. I'm going to call it Social Distance Simulator. All right, then we're going to get rid of the cat. We don't want the cat here. We're going to come in, and instead of the cat, we're going to go to our sprites. We're going to choose a sprite, and we want to pick ball. It's right up here at the top. I'm going to show you what we're going to do to this here. We're going to pick the ball, and we're going to go into the costumes. And this makes it easy for us to write the code. We're going to get rid of all of the costumes except for two. Ball A, ball B. And then we're going to come up to ball A. We're going to pick a fill. We're going to change it to red. And then we're going to come down to the paint bucket. And we're going to paint the ball red. Okay. The other one, we're going to come into ball B here. We're going to change the fill to green or a greenish color. Same thing, use the fill tool, the bucket tool, and change this to green. Now if we look at this, it makes it all nice, one simple color, whereas before the ball had kind of a shade to it. We don't want that shade, it makes it difficult. Okay, I'll give you guys a second there. And check email just to make sure nobody's having any problems hopping on. Okay. So now let's go back to our code. The first thing we want to do is, and I want this to be the red ball. Make sure we have that on the red ball. And we can actually do this by making it bounce around, or we want to make it bounce around. We can make it, as we're making it bounce around, we can actually switch the costume using code. So let's start with our, events. We're going to grab when green flag is clicked. Now we want to make this ball just move around. What this is going to do is this is going to simulate an individual, a person in society, moving around from place to place, whether it be from home to the store or just wandering through a crowd. This would be more like wandering through a crowd because it's going to be nice and open. One of the things I'm going to do is I'm going to take the looks of this and I am going to actually decrease its size a little bit. I didn't like the initial size of this because I'll show you what we're going to do later. We're going to scale up how many we can have in here, and 100% is way too big. I found that 35% is actually pretty good. So we're going to make that look 35% smaller, and that'll, when we hit that, that'll shrink it pretty good. And then we want to make sure this is always set to the same ball. So we're going to switch costume to ball A, which is red. Now what we're going to do, like I said, we're going to make this bounce around a little bit. So I'm going to come in and we're going to grab in the control a forever loop. And we're going to make this move 4 steps each time. So this is just very little movement, and we'll show you what it looks like here in a second. 10 steps I found was too fast to kind of see what was going on. And then we want to, if it's on the edge, we're going to make it bounce. So in motion, we're going to grab move 4 steps, and if on edge, bounce. And this will work, but it's not going to work well. As you see, it's going to move just back and forth. It's not going to do anything. It's not going to do anything great. All right. The next thing we're going to do is, since it's bouncing back and forth here, we need to actually give it a little bit different movement. And how we're going to do that is we're going to pick a random number, or 1% of the time, we're going to make it turn a certain quantity of degrees. So how we do that is we're going to create that random number first off. So let's go to operations. And in operations, we actually have a pick random. Now to do 1% of the time, right now, 1 out of 10, we have 10% of the time. 1% of the time is just going to be, oops, wrong keyboard, 1 out of 100. Now we want to know when this hits 1% of the time, so we're going to grab the equal sign, and we're going to drop the pick random inside the first section of that equal sign, and we're going to set that equal to 1. So what this is doing is saying, go in and every 1% of the time, every time it hits 1, pick a random number between 1 and 100. Every time it hits 1, go ahead and grab the that number, check to see if it's equal to 1. If it's equal to 1, we're going to do something. By the way, I noticed that this video kind of looks a little bit crappy. I'm not really sure, or a little bit lame. The quality might not be great. We'll work on that for next time. I'm just kind of looking at the stream as it's playing here, and it's not looking great, so we'll figure that out. We'll get better at this. All right, so now that we know 1% of the time, we need to go to control statement. Let's grab our if-then statement. I'm going to drop that right below the if on edge bounce. So this is where we're going to come in here and say, if it's hit 1% of the time, let's do something. And what we're going to do is we're going to go to motion, and we're going to turn 15 degrees. Doesn't matter which direction you turn. What this is doing is just adding some variability to it. And you can see that the ball is actually already starting to have that variability. The video is fine? Okay. It might just be because I'm also streaming and trying to watch the video too. It might be that my computer is just downgrading the video. It's probably prioritizing the fact that I'm streaming instead of trying to read the video. So, all right. So that's good. Now we have this ball bouncing around here. This is what we want. We want this to create some curiosity. And you'll notice that it kind of can weave a little bit. It can spin. It kind of creates some different movement that is not expected. And the reason that this movement is a little bit erratic is because we're not just checking it when it bounces. We're checking it all the time. So we're constantly telling it, maybe you want to move 15 degrees. Because that 1 out of 100 checks 100 times is like snapping your fingers. It's really quick. Okay, so now that we have that moving around, that's great. We have our first ball. This is what we'll call our infected, our patient 0. This is the person that's wandering around outside and out there, sick, and they probably don't even know it. A lot of the people don't know it that are being hurt by this right now. So what we need to do is we need to create all the other people. What's cool about this is we're going to use the same ball, but we're going to use the clone feature. So what we want to do is we want to go in, let's first go to variables, and I'm going to make a variable, and I'm going to call this variable people. This variable is going to keep track of how many people we want in our simulation. And you'll see why this makes a difference later. This is why we can prove that social distancing actually works. Okay, we're going to make this for all sprites. Yeah, for all sprites, that should be fine. We're going to click OK. Now people is currently set to 0. I'm going to come in here, double click this a couple times up in the corner there, and now I get a little bar where I can adjust it. I'm going to adjust it to something like 25-ish. It doesn't have to be 25 exactly, but somewhere in there. Okay, so now that we have the variable people, and again, just come down to variable, click make a variable, name it people. Your spelling doesn't have to be spot on. It's okay if it's not. Mine never is. Now what we're going to do is we're going to create a clone of this for the quantity of people we expect to be in our simulation. And I'll show you how we do this, and I'll create it off to the side here, and then we'll move it into the corner right before our forever loop here. It's going to be right at the top. So the first thing we're going to do is we're going to come into control, and we want to repeat. We're going to grab the repeat 10. And inside repeat 10, we have also in the control, create a clone of myself. So what this is saying is we're going to 10 times, we're going to go through and create a clone of the ball, because that is myself. Right now we're in the ball's code, as you can see here. So it's going to create a clone of itself. It's pretty nice, it's good. But we don't want it to create 10 times. We want to use our variable to create a certain amount of people in our simulation. So let's go back to variables. We're going to grab the people pill, drag this out. The people pill will now be dropped where 10 is to create our code to create the different people. So let's go ahead. We're going to plug this in right on top of the forever loop. So I can grab forever, I can drag it to the bottom of the repeat, and then I can take repeat and drag it into our main code, and looks good. All clicks into place. It's yellow around that border there, it means it's happy. So let's go ahead and stop our simulation, and then we're going to hit go. Now what this did was where it was at, because it creates clones really quick, it came in here, and wherever that red ball was, it created a bunch of red ball clones all at the same time. You see there's just tons of them. It's almost looking like chicken pox now. Like it's just a massive amount of them all in one spot. And what's that, Bailey? You're asking a question there, but I'm not quite getting what your question is. Oh, how did I get the line? I get it. What are you talking about the line for the variable? What you do is when it comes up first, it comes up and says people, with a 0. If you go here and just make your click on this, just double click once, and then it'll change it to the number, then double click again, and it'll change it to a slider there. And my chair is super squeaky. They're really cool. They're like these wood chairs. They like fold up and everything. They're really cool. Around my dinner table, like I really like them, but they're terribly squeaky. Okay. It won't work for you, Bailey? I'm not sure what to say there. Like I said, just try double clicking on that variable. That's how we get it to change. It's just double click. Click really quick. Like don't click slow. If I just click slow, it doesn't do anything. You gotta click fast. And if you click fast, it'll change. It's a good question though. That's a really good question. Thankfully right now it's not too important, and we can use code later to change it too if we want to. All right, so now that we're bouncing around, we're creating all of these little red dots here. It's not quite doing what we want it to do. This is part of using clones, is once we've created them, we have to actually give them the ability to perform. So what we have is in control, we have a block that says when I start as a clone. We're going to bring in when I start as a clone. I'm going to move this over here. See if we can get it all in one easy screen here. So I'm going to do some extra code in here, and I'll explain it a little bit, but just trust me that it needs to be there. And the reason it needs to be there is based on um, you know what? Never mind. We won't do it right now. We had something else that was kind of cool that I could teach you, but we'll get to that if we get to that. So the first thing we want to go to is we want to go to motion. And the reason we want to go to motion is we're going to use this go to random position block. This block is pretty cool, and you'll see right off the bat when this starts as a clone, when the ball creates a clone, go to random position is going to tell each and every ball that it creates to just pick a random point on our graph here, and this is a graph. There are XY coordinates, and I'll show you what I mean. So we have X and Y coordinates here. So it's going to pick a random X and Y for each one of these, and it's going to tell it to go to that position. It's still not going to move, but we'll get to that in a second. So check that out. It just speckled it. If I keep hitting the green flag button, it's going to do a different pattern each time. We're not moving, but we're getting close, right? Oh, good, it works now. Good. Glad to hear that, Bailey. Sometimes that double click is really picky. It gives me a hard time sometimes. All right, the other thing we're going to do to make this slightly random is we're going to tell it in the motion tab here, we're going to go to the point in direction 90, and we're going to tell it to point in a random direction. Now we have 360 degrees it can point, so we need to pick a random direction, go back to operations, and we're going to do the pick random 1 to 10. We're going to drag this in, but we're going to make this random 1 to 360. Okay, now that we have it pointing in a random direction, we do the, or picking a random direction, we make it point in a random direction. And just so anybody knows, once I'm done with this, this actually stays on YouTube as well. So if you get a little lost, or if I keep going later on, and you know, maybe we do the extra code that I was talking about just a minute ago, it will be available on YouTube. You can watch it later, and you will be able to go in and actually, you know, check the code later and see what you're doing wrong, if anything. Because right now, I'm sure that you're probably watching it and then trying to flip over to Scratch and do it, and then watch it and then flip over to Scratch and do it. So I'm trying to just condense this so anybody watching it later will have an easier time going through it, assuming that I don't edit any of it, which I might. We'll see. Okay, so now we have these pointing in a random direction. It is a ball. You won't be able to see it point in a random direction, but we got to trust that it's doing it, and we'll see that in a minute here. Because what we're going to do now is we are going to make it look green. This is our first thing we're going to do. So we're going to go back to looks. We're going to say switch costume to ball B. We have ball A is what it starts as, ball B. These are going to be all of our green people. These are going to be all the people that aren't sick. And we can see that really easy here. If we hit that green flag, there we go, switch costume to ball B, it switches it to the green. And we have one sick person bouncing around, and all the green healthy people are not moving yet. Now we need to get them to move. So we get them to move the same way we got the red guy to move. So we're going to come in, we're going to go to the control, we're going to grab a forever block, and then we're going to go to motion. And in motion, we're going to grab move 10 steps. We're going to make this 4, same as we did with the sick person. We all want them to when we're doing modeling and we're trying to prove a specific thing, scientifically we want as many of the variables to stay the same as possible. The variable that we are going to change is the quantity of people. So this is called control and test variables. So our control variables are going to be how much people are moving around. This is going to show that by distancing ourselves, it does make a difference if we're all moving around at the same pace. We could give it random steps, random movement to each person and see how it spreads. That could be another test that we do. It probably will tell us about the same thing though. All right, so let's do move 4 steps. We're going to grab if on edge bounce, that's in our motion as well. So if on edge bounce, and then we want to turn them as well. We're going to make them move around. So same thing we did down here. And so let's go to control, if then, and you could copy this, you could duplicate this over if you wanted to. I'm doing this the long route so that we definitely understand what we're doing. So we're going to pick random 1 to 100 so we can get that 1% chance of movement. Then we want to check to see. We're going to grab the equal sign, check to see when it is 1. Let's drop that in there. Looks good. Looks the same so far. We want to compare these two. Looks the same so far. And again, it doesn't matter which direction they move, whether it's clockwise or counterclockwise. I'm going to grab the same anyway. And we should have movement now. All we did was just duplicate what we had over on our sick person. Again, we want to keep the variables the same with testing. So now, look at that. We have everybody moving around, just random people moving in different directions. Okay. So this is good. Now we have simulated movement in a crowd, movement in a society. This is nice. This works really, really well. When I started building this, I had not taken a look at other simulators. I did find some simulators the next day after I had built this, and almost all of the simulators did the same exact thing. And these were people trying to prove the same thing. What we're trying to prove right now is that social distancing does work. Me not being there with you is valuable. But we can thankfully with technology, we can share this information, right? Okay. So now what we need to do is we need to infect people. So this is the fun part. We need to go in and we need to say that when that red ball touches one of the green balls, that we need to say that that green ball is now infected, which means that they are going to have to turn red as well, because when they touch another green ball, they will also be able to infect someone. This is how infections spread. Sure, I'll let that message come through. Why not? I like I think that's a train. Oh no, I like the Ferris wheel. Ferris wheel's cool. Okay. So now to do this, we only have to do this on one of the balls. So our patient 0, if we can call him that, our single red ball, the red ball, we don't have to worry about it touching anybody else. We only have to know when a green ball is touched by a red ball. And that's the clone here. We're going to see that in the clone. So what we did earlier was we changed these green balls and these red balls to a nice solid color, and this is why we changed them to a nice solid color. Is we're going to go into sensing, and in sensing we're going to see when color is touching another color, and this is what we're going to use right here. So we want to know when a green ball, and we can do this by clicking on that color, and then down at the bottom here you see there's a little button that'll give us a target. And I didn't grab it. Let me stop this. And this is the pain part here, is trying to get one of these. I'm going to actually tell it to stop moving for a second. There we go. So I'm going to say, tell everything to stop moving, and grab the green color. This is kind of cheating. I like it. This works really, really well. And then we're going to put that movement back in there. Then we're going to tell this one stop moving so we can get the red color. All right, let's grab red. There we go. So we got when color green is touching red. Now let's put my movement back in the forever block there. We could do this the long way by going into the costumes and actually trying to see what the color was. We can do the same thing here. We can tell it, tell me what color this is, and it says 0, 100, 100. We can do the same thing with green. Come in here, click on the fill, click on the eyedropper, click the middle, 35, 100, 100. We could come in and do the same thing over here. Oh, see, we're close. This is supposed to be 35. 34 should work too, but I can change it to 35. There we go. 35, 100, 100. So there's a longer way of doing that. Just moving this out so that we could see it work better for the moment. All right, so we want to know when this is happening. We know when this is happening by using an if-then statement. So I'm going to drag this into an if-then statement. So I can say if color green is touching red, then we need to do something. And what we're going to do is we're going to say that this is infected now. And we're saying that by switching the costume. So we need to go into looks, and we need to say switch to next costume. And we're going to drop this. Let me double check, make sure I'm right. We're going to drop this right at the bottom. Yep. Now, when I start this, check this out. When I start this, now when the red touches the green, oh, unless did I do something wrong? I did something wrong. Let's see what I did wrong. Interesting. Okay, what am I doing wrong here? Let's see. Oh, well, it did want 34, 100, 100 for me. Don't ask me. Okay. That's why I like doing the method of just freezing the balls for a second and then going in and trying to adjust it. Works easier. It's less picky. Okay, so you saw that. Look at that. So we started off with all these green, and then infect one, there's another, and you see how all of them just start to infect each other. Now let's move this up. Let's see if we can make this panic a little bit. We're going to move it all the way up to 100. Now when I go all the way up to 100, look at that. It seems to spread faster. But can we prove that it spread faster? This is what we're going to do next, is we're going to prove that the spread is different from 100 to even, let's say, 13 people. 13 people, there's a lot less on there. Definitely looks like it's spreading slower. Seems to be. But we need to prove it. And we're going to prove this by creating a graph. And we're going to use a sprite on here to draw a line on the background that will show us how quickly this increases. Good. Glad you did it, Bailey. That's awesome. Okay. So what we're going to do next, I like a specific sprite for this just because it means something to me, is I use arrow 1. So let's go ahead and let's grab arrow 1. And the reason I like the arrow is because it tells me which direction the sprite's facing, which is going to be important for our graph. So let's grab arrow 1. It shows up here. It's nice and big. We're going to kind of move it down to the bottom here. And I'll give some coordinates of where we want to put it here in a second. So the next thing we want to do is we want to go in and grab the pen. Now, I don't know if you guys are familiar with this, but down in the bottom corner here is this little blue button with a plus sign. We're going to click that plus sign, and we're going to use the second one in. We're going to use pen. Okay, so let's grab the pen tool. When we click on that, it adds a whole new section for us. We're going to use just a couple of these tools. We only have to use them in a certain order once, and then once we set them up, we don't have to worry about them too much. So we'll get to those in just 1 second. I just want to prep that. And the last thing I want to prep is I want to make a variable, and we're going to make the variable, and we're going to call it infected. And we're going to make it for all sprites, because we do want both sprites to use this variable. Okay, so we have our infected variable. What this is doing is this is going to tell this is our pen program here, how to move and in what way to move so that it creates a proper graph for us. So let's start where we always start. Let's go to let's go to events and grab the when green flag is clicked. So the first thing I like to do here is I don't want that arrow showing up. It's kind of distracting, but we still need the arrow to exist. Now what we do with this, and we'll talk about this a little bit more. I want to get Oleg to teach you guys how to do these like hidden doors or hidden click boxes. It's really cool. He was supposed to teach it last week with this whole problem. We didn't get to it. But we use this same trick with hidden click boxes to hide stuff, but make it there just enough to where we can find it, where when we click on something, it's actually available to click on. If we actually just hide this completely, it's not going to do what we want it to do, at least not properly. So what we're going to do is go into looks, and there is a set color effect to 0. Let's drag this out. We're going to take color though, and we're going to change color to ghost. And then we're going to change the effect number to 99. So what we're saying here, if you watch this arrow, when I do this, this arrow is going to disappear. It's only going to be 1% visible, which is extremely, extremely small. Okay, so set ghost effect to 99. When I click this, look at that. The arrow looks like it disappeared. It's actually still there. It's only 1% visible, which is extremely small. We keep it 1% visible so that we can move it around, we can do things with it, we can tell it to draw, we could still click on it if we wanted to, but the user can't see anything. And you might see yours still. It's again 1%, 99. I mean, 1% still there. It depends on your screen, depends on your monitor, depends on a lot of different things. It's still in there. In fact, I don't know if we zoomed in if it would even start to show up at all. I can't see it on mine. but still mostly invisible. Set it to 99, effect to 99, set ghost effect to 99. The next thing we're going to do is we're going to set it to only be 10% of its initial size. So we're going to come in and we're going to say set size to 100%. We're going to change this to 10%. And this is going to make it a lot smaller. And this is, if I set this back to 0, we could see that it's super small now. Just kind of what these are doing is this is getting it out of the way. It's making it so where we can not worry about actually seeing the arrow itself at the moment. If we need to, we can. But what we're trying to do is just put it in a situation where we can use it but not have to worry about looking at it. The next thing we're going to do is go to motion. And we're going to set the starting position for this. So we're going to say go to X, Y, and the numbers we're going to give here are, we're going to go to X, negative 240, and we're going to go to Y, negative 160. Okay? That was in motion. Go to X, go to Y. What this is doing is this is setting this arrow all the way at the corner over here and down fairly low, about right there. And you'll see when it starts to draw, you'll see why we do this, especially when we have a different quantity of people. It will, the chart will increase quicker, and so we want it to be nearly, just pretty much as low as possible, but we still want to see it when it starts drawing. All right, now we need our pen tools. So our pen tools here, we're not doing too bad. We're going to 55 minutes. Okay, so our pen tools here, the first one we're going to want is erase all. What this does is each time this starts up, any graph that we've already created, it's going to erase it. And we do this so that we don't get graphs confused. The next thing we're going to do is we're going to tell it to put the pen down. This means that the pen comes down and touches the paper, or in this case, our background. This tells it to start writing. I'm going to pick a color, so I'm going to set pen color, and I'm going to set this to a blue. So I'm going to turn the brightness up, and turn the saturation up, and I'm going to set it to a pretty blue color here. And this is just so I can distinguish the difference in colors so that the red and the green and the blue all look different. You'll notice it's red, green, blue, RGB. It's a pretty common color scheme that we use. And it's because it's the very raw colors of a pixel. All pixels are RGB in some way. And then we're going to set the pen size, not change pen size, do set pen size. And we're going to set that to 2. All right, so this sets our pen. This gets it ready. This is all we have to do with our pen. We don't have to worry about it anymore. It just preps our pen. It tells it to start drawing at the beginning. It erases everything. It makes it look nice. The size is appropriate to where we can see it. It's move the arrow to draw our graph. So how we're going to do this is we're actually going to tell the arrow to move all the way across the screen. And to make our graph formation, when more people get infected, to make the graph go up, we're going to change where the arrow's location is on the screen. So right now, what we need to do is we need to come into Control. We need to grab the forever loop here. And then we're going to go to Motion. And we're going to say move 10 steps, but we're going to change this to 1. You want it to be 1 because we want to show over time. So what this is doing is it's moving 1 step about every second or so. And you'll see why this is important. If we make this too fast, our graph doesn't show up very well and kind of causes some problems. So let's just try this. Let's stop our simulation and let's start this. Now you'll see that the blue line across the bottom here, the blue line is moving across the bottom, but it's not going up as people get infected. All right, so now we need to actually collect when people are infected. So before we set our graph to do this, before we set our graph to show how many people are infected, we have to collect that, and we haven't been doing that yet. So what we're going to do is we're going to go over to the ball, and in the ball, where we have, let me make sure I get this right. Yes, where green color is touching red, we have next costume. We want to go to variables, and in variables, we are going to click and drag change infected by 1. So what this is doing is each time someone gets infected, it should show on our graph that they're getting infected. We can actually see it up in our number here too. If you still have the number up in the top, let's stop our simulation, start it again. You'll see that as soon as someone's infected, there we go. Someone's infected. There's 1, 2, 3, 4, 5, 6, 7, 8. All right, it's working. You should see that working. A lot of the times what happens, there's a lot of things that look the same in Scratch but are named different things. For instance, change infected by 1. There's also, set infected to 0. They look very, very similar. We don't want set, we want change. No worries, Bailey. It's okay. Again, if you need to, go ahead and pause this. I think you can pause the live stream too. I'm not really sure. I think you can. But it should look good from here. This is all working well. We just need to make sure our graph is now functioning as it should be. We haven't got that far yet. So let's click back over to our arrow. Now that we're collecting how many people are infected, we need our arrow to display that. We need it to create a graph here. So what we're going to do is, like I said, we're going to change the height that the arrow is on the graph here. So let's go into motion. And in motion, we are going to pick set Y to -160 is what I have it at right now. Now we need to do a calculation for this because we want the arrow to stay at 160 as its baseline, or -160, excuse me, as its baseline, and we want it to move up from there. So what we need to do is we need to decide how much we want it to move up for each person that's infected. You're gonna have to trust me. I played with this a little bit. I found a number that worked. Pink, you picked pink, that's okay. So what we're gonna do is we are gonna go into operators. And in operators, we're going to pick 2 of these. We're going to pick the multiplication, and we're going to pick the addition. And what we need to do is then go into variables, and we grab the variable infected. So we need these 3 together. We need the addition, we need the multiplication, and we need the variable infected. Now we need to make sure we drop these in the right order. They need to be in the right order, otherwise they won't work properly. So the way this goes is we are going to drop the multiplication into the addition, and then we're going to, actually here, let's try it this way instead. We're going to drop infected into multiplication, and then we're going to drop multiplication into addition. So if we're reading it from top to bottom, top being closest to us, we have infected, then we have multiplication, then we have addition. Okay? And then we're going to drop this inside the set y2, and we're going to override -160. Okay. Now, trust me on these numbers. In the first one, we're going to have -160. That's our baseline. That's where we want things to start. That's where we want this to count up from. That's where we want the graph to start and move up from. And then the multiplication, I found that a factor of 3 looked really nice. It fit well. Okay, so what we're going to do is we're going to drop this right below the move 1 step. So now we have move one step and then this right here. Now check this out. Watch what this does. Okay. We are going to now, thought I'd give you guys a second there to catch up if you needed. This is going to now move this line. As it runs across like it did before, as people become infected, it's going to move this line up. So let's watch here. We got 2 infected. Oh, we did something wrong. We got 19 infected. We forgot one thing. You're going to have to forgive me for this. Is we forgot to reset the number of people infected. And we need to go into variables, take set infected to 0. And we need to drop this right at the top, right below the ghost effect. So now it should start at 0. There we go. All right, so let's try this again. We have 0 people infected. We're not counting patient 0 right now. So look at this. This takes a long time. It's not even hit anybody yet. It's a terrible example to show a graph. Oh, there we got 1. Look at that. Our graph finished before we could even show all the people. So let's move this up. Let's move it to about 30 people. And let's restart our simulation. Here we go. Now we're getting people a lot quicker. Look at that. Look at our graph building. There we go. Everybody is infected. Our graph is going to level out at the top there. We don't have the people becoming not infected anymore, which is actually what happens. We could take this even farther, and we could say that people are healing and becoming better, and that's going to be those dots would turn back to green. Maybe not green. Maybe we would make it another color, show that they're healed, like purple or something like that. But we can see our graph there. See how it's got this gentle slope. This is called, I think this is a logarithmic slope. Let's pump this up though. Let's jump this to, let's say, I don't know, 80 people. And let's do this simulation again. Now watch this line. Watch how quickly this line goes up compared to the other one. So this is called an exponential. So this means that it goes up extremely quick. It is going to flatten out eventually because all these people are just isolated with each other, but it shows how quickly those people get infected. Now let's go all the way to 100. Look at that. Before we even officially really started, it just started infecting people very quick because someone ran into the infected person before they ever moved around. Now look at this one. This one goes up even quicker than the other one. So this is, by looking at these graphs, this is actually, we've created something that shows us why we need to keep our distance from each other, why we're trying to protect each other, is because looking at a bunch of people in one spot, we see with a computer model that the quantity of people infected is a lot really quick. But we can change those people around and show that it takes longer to reach the maximum quantity of people infected. This infects the maximum quantity at, oh, we haven't even hit right there. Okay. So we're about 3/4 the way through our graph here before we hit maximum quantity of people infected. But when we change it to 100, the maximum quantity of people infected, let's see how long this takes. We're going to go up, 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 up. We hit maximum right there. We're only 1/4 of the way through. That is a massive change. So we can prove, again, with computer modeling, that keeping a little bit of distance from each other actually does benefit us. It will slow the progression. It will take longer for it to spread around. It complicates things when we're all in a tight space together. You see how quickly a virus can move around. Because with this virus, it is simply through touch. And that's what we're doing in this model, is when one thing touches another, that passes the virus. So we're creating a model that is very similar to the way that this functions. There is more that we can do here. We could show like blocking different people off and show how people can get infected in different areas. We're not going to take care of that right now. There is some cool stuff that we can do. If you guys are interested, leave comments on the video. You can ask questions. I'm more than happy to answer questions. And I'm going to call this pretty much quits for tonight. I think that we're doing pretty good. It's 7:30. Like I said, it was about an hour long. We will have another lesson next Thursday. It is, what is today? Thursday, I think it's the 19th. Yes. So we will have another lesson right here, Thursday, the 26th, at 6:30. And I'm not sure what we're going to do yet. It might be me teaching. It might be somebody else teaching. Other teachers are willing to do this. We just need to get everything set up. Hopefully we'll have a better microphone. I'm hoping that we will kind of upgrade our systems to do this a little bit better each time. So it just takes time, takes some effort, and we'll get through it. Again, please leave comments. If you have a account, you can subscribe. If you want to like it, that's great too. If you want to know when we're live again, if you subscribe and then there's a little bell next to the subscribe, if you click that bell, it will send you notifications. That'll let you know that we're back on. The next one, I will probably set it up to notify that we're going to be live streaming before we actually live stream. There's a way that you can do that to where you essentially go into the streaming and you say, I'm going to stream on the 26th at 6:30, and it will put something up there and it will hold that for us as a spot to let all of you know if you subscribed and you've clicked notifications. It'll say, hey, just so you know, at 6:30 you got something to watch. So again, any questions, go ahead and leave them in the comments section. I'm more than happy to answer anything. And also futurecode.org. We just updated the website. It's looking okay. It's got some bugs in it. It doesn't look great on phones right now, but it's looking a lot better. On futurecode.org, we also have our Twitter stream. So we're going to start tweeting a little bit more so that people can see what's going on, especially as we go through this trying time with each other. Communication's the best thing we can do, so we're going to keep it up. That's why I spent some time in the last week rebuilding the website from the ground up. I mean, I ripped everything down, rebuilt it all. It looks great. It's starting to look a lot better. I have someone who's a better web developer than me working on it too. It's going to look really, really good soon. So use it as a spot for communication. You can check out those tweets. I will let people know what's going on. And again, use the comments. So anyway, I will see you guys all next Thursday. Hopefully we'll have more people. Bailey, thank you for all the communication. You're awesome. You had good questions. I hope this worked for you. Again, if it didn't, leave me some comments and I'll help you out. And again, we'll see you all next Thursday. Thank you so much. I appreciate it. And stay healthy, you guys.